Welcome students, welcome to Yupp Master, the school foundation program. I am your chemistry teacher Dr. Sripad Rao. So, in the last class we have gone through the introduction part of the foundation program. So, today let us start the what is exactly the topic which we are supposed to start. Okay. So, here we are going to look into the physical classification of matter first. So, we start with the basic concepts so that you can easily understand what is chemistry we have learned in the previous classes. Okay. I think by this time we have a complete idea about the science as well. So, what is science exactly? So, when you look at the science, we generally define the science as the continuous human effort to systematically understanding the nature. Okay. So, chemistry is one branch of science where we are going to learn about the atoms and molecules. Again, atoms and molecules, their composition, their structure, their chemical and physical properties we are going to learn. So, again it is taken in terms of matter. Okay. So, what is exactly the matter is? So, which is called as matter? How to classify the matter in a physical sense? How we are going to classify the matter in physical classification? So, all these things we are going to learn in this particular class. Okay. So, what is matter is? We know that matter is anything which has mass and occupies some space. For example, I am a matter, I have some mass and I can occupy some space. Similarly, you are also matter, you can occupy some space and you possess some weight, that is mass. Okay. So, anything which is going to has mass and which is going to occupy some space. So, occupying some space and possessing the mass is generally considered, that particular component or object is taken as matter. For example, air, if you take air whenever as we open the door, what happens? Air will come into the room. Okay. I think whenever somebody is using a very well fragrant scent or deodorant, so as soon as the person enters the room, so we people start feeling that smell. So, here the perfume that we have used there, the air component of the perfume or the gas that is used as a perfume is spreading throughout the room. So, it is going to occupy some space, and generally we know air is going to have mass. How we can determine the air has mass? Take two balloons, let us say to a stick we are going to tie two balloons. Okay. So, if one of the balloon has a big size, automatically that side that stick is going to be tilted. Okay. So, that side the stick will move little downside. It indicates that here we are using air and here also we are using air. So, two balloons are filled up with air, okay, and air is going to occupy the space available in that balloon. Okay. So, it is going to occupy some space and it has mass. See, large size balloon way more compared to the light sized balloon. Okay. So, small sized balloon. So, automatically the large sized balloon has mass when compared to this one, and of course, this is also has mass. So, air is going to occupy the space that is provided to it, and it is going to exhibit weight also, exhibit mass, it is going to possess some mass. So, anything which has mass and occupies some space is matter. So, air is matter. Food, for example. So, if you are preparing rice, dal, chutney, etc., if you take their weight, they of course, they are going to have some weight. Okay. The pulses that we are used, the food grains that we are using, they are going to have some weight. So, the weight, they are having weight and they are going to occupy some space, they are going to occupy the space in the bowl, right. So, food is best example of matter. Stones, I think you have seen so many stones in your school ground. Okay. So, the stone is going to have some weight. When have you taken the stone into your hand? I think so, right. So, the stone has some weight and it is going, if you throw it on the ground, what happens? It is going to occupy some space on the earth. So, stone is taken as matter. Okay. Similarly, clouds will occupy the space, right, and they are going to have some weight as well, because it is a water vapor. Water vapor means it is going to have possess and is going to have some weight, that is mass. So, clouds are also has mass and they are occupying some space. So, cloud can also be considered as matter. For example, if we take stars, stars are present, you can, I think you can enjoy the beautiful stars that can be seen on a summer night when you sleeping on the terrace, right. So, you can see the beautiful stars, their grouping of stars into different structures, you can imagine different structures over there. So, stars are also, for example, sun has mass, sun is going to occupy some space. So, star can be taken as matter. Animals like us, okay, human beings, the cows, animal, buffaloes, dogs, cats, rats, etc. All the animals, they will have some weight and they are going to occupy some space. So, animals are taken as matter. A drop of water, for example, if I am taking a glass of water, water will have a weight. If I take 2 glasses of water, weight will be more. If I am going to take 3 glasses of water, weight will be still more. So, as the amount of water increasing, weight is also increasing. So, water is going to have some mass and it is going to occupy some space. It is going to occupy the space of the glass in which it is stored. So, water can be considered as matter. So, of course, we can take so many examples. Simply observe that anything, if it is has some mass, okay, if it is weighing and it is going to occupy some space, then in that case that particular object can be taken as matter. Okay. So, all the, for example, book, the books that you are using or you are taking in your bag. So, of course, you know the weight of the books that you are taking to the school, right. So, the weight, the book is matter, it has some mass, it has some weight and it is going to occupy some space. If you keep the book on the table, it is going to occupy the space. So, book is a matter. The pen that we are using, pen will have some weight, okay, and when you keep the pen on the table, it is going to occupy some space. So, pen is a matter, okay, and the lunch box that you are taking, the box will have some weight and it is going to occupy some space. So, lunch box can also be considered as matter. So, everything or anything which has mass and which is going to occupy the space can be considered as matter. Of course, feelings like anger, hungry, sad, all these cannot be considered as matter. Why? They does not have weight, they does not occupy some space. So, anything which has weight or mass and it is going to occupy some space is generally taken as matter. So, all these are examples. I think you got an idea, clear idea about the matter, okay, right. Let us move on to the properties of matter, how we are going to look at the matter, what are the properties of matter. So, let us see. Of course, this is the first one, they are going to possess both mass as well as volume. It is going to have mass and it is going to occupy some space. It is occupying some space means it is taking some volume. So, matter is going to possess mass as well as volume. For example, if I take pen and let us say pen is weighing, let us say 0.5 grams, okay, and if I am keeping the pen on a table, what happens? It is going to occupy some space. Similarly, table will weigh, let us say it is weighing 500 grams, let us say small table, okay, and when you keep it on in a room, automatically it is going to occupy some space. So, it is going to occupy some volume. So, matter will possess mass as well as volume, okay, right. This is the first property that we can observe from matter, right. And when you observe how the matter is made up of, matter is made up of very small particles, and of course, we will come across how the matter was classified, how it is made up of and what are the particles were known, all these things we are going to learn in the next classes, okay. Let us at present scenario just observe that or just understand that matter is made up of very small particles and in these particles, between these particles, what is present? Intermolecular spaces are present. So, matter is made up of very small particles and between these particles intermolecular spaces are present, okay, and these particles attract each other and are in continuous random motion. They are going to attract each other, okay, and they are in a continuous motion. For example, if I take this pen will has a mass and it is going to occupy some space, so it is matter. It possesses mass and it is going to occupy some volume. So the first characteristic is property is found out. And when I look into this one, the combination of so many components resulted in this pen, okay. So what are the particles that are present? The small particles that are present in the matter are responsible for making this pen. And what is if I look deep into this particular pen, what happens? I can see that between these particles intermolecular spaces are present. So intermolecular spaces are present between the particles. And one more thing, that is that the particles will start attracting each other, therefore the pen is in a tight position. Otherwise the particles, if they are not attracting each other, then the one particle will go this side, other particle will go that side, so automatically the pen will not be in a correct position. So we cannot consider it as the matter. So generally the particles will attract each other, and in that process they are not sitting in a silently in one position as you people sit in a class, okay. So it will be in a continuous random motion. If I am giving the matter to occupy this particular room, automatically what happens? The particles will move in all possible directions. So the movement is continuous. So they are continuously going to move with one another. Let us say, for example, if we are going to take a cubical box, okay, and within this cubical box, if I am enclosing oxygen gas, let us say, okay, oxygen gas, it has mass, okay, oxygen gas has mass, and also it is going to occupy some space, it is going to take some space, or it is going to take some volume, right. So within this cube, if I am going to enclose the oxygen gas, let us say I have the oxygen molecules, I am representing with the circles, okay. Let us say these circles are present as oxygen molecules within the cube, and when you observe these components, or when you look into the complete picture of the matter, what is happening? There are some spaces. For example, if you observe, each and every circle is separated some distance. So the distance that is present is generally taken as intermolecular space. So intermolecular spaces are present between the molecules, and the molecules are not in a silent position. What they are doing? They are moving in a random fashion. So one molecule is moving downward, other molecule is moving upward. So all these things you can clearly observe in the matter, that the particles are present. Of course, the oxygen gas is made up of some small particle, and these particles are present in the given space, and they are having some distance between them, and the empty space between them is taken as intermolecular space. And moreover, the particles are not sitting silently, they are not silent at all, they are moving in a random fashion, they are moving in one direction. One particle is moving upward, other particle is moving downward. What happened during these motions? Of course, the collisions are possible. For example, in your class, if you are not, all the students are not sitting in a silent position and in a particular position, and if they are running in a zigzag motion from one corner to other corner, what happens? The students will collide with one another. The same thing is going to happen in the case of this matter as well. So here I have taken gas, so the gas molecules are colliding with one another during their motion. So continuous motion, random motion, that too it is not a particular position. What do you mean by random motion? Random means the movement is in all directions, irrespective of direction. It is not only along the x axis, not only along the y axis, not only along the z axis, it is in all the directions. So it is going in a zigzag fashion, this way, that way. So one molecule is going this way, other molecule is going that way. So one molecule is coming from top, one molecule is going from that bottom. So all these particles are moving in a random fashion. There is not a fixed position, it is not a fixed motion, it is not a fixed velocity. Moreover, one molecule is moving with high speed, one molecule the particle is moving with the slow speed. So different speeds are present. It is not exactly all the molecules are having the same speed, no. Different molecules are having, or different particles will having different speeds. They are moving in random motion. So we can say that when you observe the properties of matter, they possess mass as well as volume. They have mass, that is weight, and they are going to occupy some space when provided. Okay. Example, books and pens you can clearly see. And when you look into their internal structure, when you go into the deeper structures of the matter, you can see that they are made up of very small particles, okay, and moreover the particles are separated from one another and there is some space present between the particles. So, that space is taken as intermolecular space, empty space that is present. Okay. I think you have seen how the a building is built. For example, you are living in a home, right? How your home is made up of? Your home is made up of the bricks, right? I think your home is containing one bedroom, one hall, one kitchen and one dining room, etc., right? How these components are made? Through one small particle, that is bricks. So, bricks are present. So, bricks are responsible for making your beautiful home, right. So, how the bricks are attached with one another? The bricks are attached with one another by using the cement and other components, right. So, the similar fashion, matter is also made up of a small particle, that particles are separated from one another and the empty space that is present between these particles is taken as intermolecular spaces. And moreover, of course, the bricks will be in a tight position, they will not move at all, right. In a for a building, when you take the bricks will not move, if it is moving then the home will not stand for long time. Here in this case, if you observe, in the case of matter, the particles are not continuously in a constant position, they are in a continuous motion, that too a random motion, it is not a particular direction motion, all particles are not moving in the same direction with the same velocity. They are moving in a zigzag fashion, one molecule moving that corner, one molecule moving this corner, one molecule is moving upward, one molecule is moving downward. So, the particles are moving in a different directions, and of course, since the particles are coming to near to one another, how they are coming near one another? Because of the attractive forces that are present, and some molecules are moving away from one another, how they are going away from one another? Because of the repulsive forces that are present. So, intermolecular forces or interatomic forces or interparticle forces are present, which are responsible for keeping these molecules in a near position and moving them with one another because of the repulsive forces. Repulsive forces, attractive forces, all these forces are operating, and because of these forces the particles are present in that particular matter. Of course, when we go for the physical classification, as we divide the matter into different portions, how the particles are arranged, how the space is present, how fastly they are moving, all these concepts we are going to learn in the given concept, this particular topic matter. Okay, right. Let us see how we can classify the matter. So, generally we can classify the matter into 5 categories. First one is solids. I think you have come across so many solids in your daily life. You will come across so many solids in your daily life from the beginning, morning to evening. The brush that we are using is a solid. Okay. The bucket that we are using for the bathing purpose is a solid material. Okay. And the mug, jugs that we are using, the plates that we are using for tiffin is a solid. Okay. And the food that we are taking is, of course, it is a half solid cooked one. Okay. Automatical, that is also can be considered as a solid. So, the dress that we are wearing all comes under solids. Okay. Liquids, we are going to use so many other liquids as well. Water, we have to use for drinking purpose, we have to use it for cleaning purpose, we have to use nowadays sanitizer, alcohol based. What is alcohol? Alcohol is a liquid, sanitizer we are using in a liquid form, right. So, sanitizer is a liquid. So, matter, sanitizer can be liquid. So, matter we are taking here as a liquid. Gas is one more the classification, physical classification of matter. Gas, if we observe, the air present around us is a very good mixture of gases. So, it contains nitrogen gas, the main portion of air is nitrogen, and then we know oxygen is required. Oxygen is the second major component of air. Okay. Oxygen is required for existence of the life on the earth. So, gas is also, here the gas is one part of matter, that is matter can be physically classified into solid, liquid, gas, and we are going to see some more classifications. One is plasma. Of course, what is plasma? We are going to discuss all these matters and their compositions in our discussion. So, plasma, and then we have a Bose-Einstein condensate. Of course, these are recently added matter classification. Generally, in general, whenever we say, or if you observe the components present around you, if you look at the components that are present around us, you can clearly say that matter can be solid form, or it can be in liquid form, or it can be in a gaseous form. So, we can see the different solid, liquid, gaseous forms of matter in our day to day life. Okay. Plasma and Bose condensates can be seen at a particular conditions of temperature and pressure. There we are going to explain what are the conditions that are required for the existence of these matter classification. Okay. Right. Let us look at solids, how we can explain the solid or how to identify the solids. You know, the solids will have a definite shape and definite volume as well, they are going to have definite mass. Okay. If you observe here the particle, if you look at the arrangement, they are orderly arranged, and we know the small particles are arranged in a neat ordered fashion. These are the particles of the solid. Okay. As I just now we have discussed, matter is going to possess some mass. This cube, let us say this cubical form is going to have some mass, it has some weight, and when I put it on the table, it is going to occupy some space. So, it is a matter, and it is made up of constant particles. So, I am taking the inner view of the solid, and if you see the particles are arranged in a ordered fashion, and if you observe the particle here, so you can clearly see the particles are separated. There is a small gap that we can see here, that is taken as intermolecular spaces. Intermolecular spaces are present. So, distance is present between the molecules, you cannot make the molecules to come closer rather than this. Okay. And moreover, how these particles are sitting side by side? Because of the attraction that are present. So, because of the attractions they have, they will come closer and they will pack together. So, this is the case in the in case of solids, we can observe this kind of arrangement. So, matter can be classified into solid, liquid, gaseous, plasma, Bose-Einstein condensate, and first of all, if you observe the solid, solid can be clearly seen here as a beautiful explanation through the video. You can see here that they are going to have a shape as well as volume. So, you can see the shape and it is going to occupy some space as well. Okay. So, you can see that the particles are arranged in a beautiful neat arrangement. The particles are very small and they are fixed in their position, they are not moving at all. So, this is the case of solids. Okay. So, if you observe these particles, the particles are separate from each other and all the particles are arranged in a beautiful ordered fashion. The reason is that they are going to have some attractions. So, attractions are playing a major role in the case of matter, that too especially in the case of solids. Okay. Let us look at how we can take the solids properties. So, the same thing I am representing here. If you observe here, all the particles of the solid are arranged side by side, and you can see here the gaps are present. So, intermolecular spaces are present. So, all the particles are sitting side by side in the case of solids, and between the particles we have some spaces. So, the intermolecular spaces are present within the solid. Okay. So, here if you observe, the atoms are packed in a neat orderly arranged pattern. Okay. And it is going to possess some weight, it will have some mass and it is going to occupy some volume as well, space as well. Okay. For example, if you take the crystal, sugar crystal if you observe cleanly, it is in cubical fashion or cubical pattern, and if you observe it internal structure of that one sugar crystal if you take and if you observe the internal structure, the particles will be arranged like this. Okay. So, in the case of solids, what is going to happen? The molecules are closely packed together, they are closely packed. Packing will be very close in the case of solids. Okay. You can see here the packing is very close. So, all the molecules or all the particles of the solid are arranged in a ordered fashion, that too with a closely packed manner, closed packed, and because of the close packing, can we expect a more amount of empty space within the particles? For example, if I am arranging the particles this way, okay, we cannot get any space between the particles. The space between the particles is very little, okay. But if I am going to take the particles in this fashion, what is happening? The space is large now, and you can also divide it. Of course, we are going to see the arrangement of particles in the case of the solids as well as liquids as well as gases. We come across the different arrangement of these solids, liquids and gases. So, if you observe here, the molecules are closely packed together with a little empty space, very less empty space is present between the molecule. Let us assume these balls are molecules and they are packed closely, okay, and when you observe the space present, the intermolecular space or the empty space present between these particles is very small, it is very less, okay, right. Molecule cannot move freely in this case, since they are packed tightly. This particle, can it move? Because here upward, downward, left side, right side, all particles are present. So, this cannot move at all. So, molecules cannot move freely. So, the movement of molecules is not possible in the case of solid. This is a solid particle. If I throw it here on the ground, it will stay there only, it will not move anywhere. Okay. So, the particles are arranged packedly and the space, empty space is very less in between these particles. So, we cannot expect them to move in a random fashion. So, the movement is very less. So, they cannot move freely. So, free movement of particles is not possible in the case of these classification of matter, especially solids. Okay. Hence, they possess, because of the arrangement and little space between the particles, and since they cannot move, they are going to possess definite shape. They will have a particular shape and they are going to have some volume. For example, if I take this remote, so this is having a particular shape and it is going to occupy some volume. If I take this pen, this is going to have a particular shape, okay, and it is going to occupy some space. So, it is having a definite shape and as well as definite volume. Best example, if you take rubber, salt, glass, remote, pen, okay, the powdered components, okay, sodium chloride crystals, sugar crystals, rubber, the food grains, okay, all can be taken as solids. So, they are going to occupy, they are going to have the arrangement of atoms in an ordered fashion, closely packed together with a little empty space, and the molecules cannot move with the freedom, and because of that they are going to possess definite shape as well as definite volume. So, solids possess definite shape, definite volume. Okay. Of course, there are so many examples you can cite with respect to the solids, right students. I think we have enjoyed this class today, and we are going to come up with some more concepts in the